Şimdi sıradaki konuşmacımız Fortes Plus'ın CEO'su. Kendisi aynı zamanda ISTQB'nin ileri seviye test analisti çalışma grubunun yazarı ve eski bir üyesi. Karşınızda alkışlarınızla Istvan Forgacs.
Hi, everybody. First of all, the light. I'd like to thank Okan to invite me, and congratulations for this amazing first test conference in Istanbul. And yeah, I'm Istvan Forgacs from Budapest, Hungary. We are all friends. We've got some Turkish words and some culture when you visited Hungary for about 150 years. So thank you. And yeah, my presentation will be a little bit technical. But first of all, something about me. I've been dealing with software testing for about 38 years. I originally was a researcher at the Hungarian Academy of Sciences, but I went to the industry. I'm the co-author of these 4 books, and with my co-author Attila, we developed the testdesign.org website, which I think is the only website you can exercise test design by applying a mutation testing framework. And with Attila, we also introduced some new test design techniques. And I will speak about this two-phase model-based testing, which is also new. Okay, so for me, one of the biggest problem of software development is bug fixing, because the bug fixing cost is really huge. Only in the United States in 2022 was about $600 billion, and I think worldwide it's above $1 trillion. But it can reduce, because the main problem is that lots of bugs are detected only after release, so in the maintenance phase. And we should use the shift-left method and detect lots of bugs in the design phase, or if not, then at least in the testing phase. And with our new methods, it can be done. So currently, almost every larger company uses test automation. But this is not test automation, it's just test execution automation, which is different, because during test execution automation, the developer coded the test cases one by one without any deep test design. And the result is the non-reliable test cases and the poor code quality. Another problem with the test execution automation is that the test code writing is rather slow, and the maintenance is very expensive. So the solution is that test design automation is needed. For me, test automation is test design plus test execution automation. But what is test design automation? It can be anything. There are several algorithms for this, but mainly it's model-based testing. During model-based testing, from the requirements or any oracle, we make a model, and from the model, a tool generates test code automatically. There are three basic classes of models. On the left-hand side, you can see the state chart. In the middle, there is a flow chart where there are no states, and on the right-hand side, you can see the well-known use case model. But even from this textual model, a graph can be generated, which is very important, because based on the graph and traversing the graph, different text selection criteria can be applied for different risk levels. There are several advantages of model-based testing. The models are more compact than coding. Manual testers can be involved in the test automation process because the test cases are regenerated from scratch. There are no obsolete tests, and there is no need for refactoring. One of the biggest advantages is that the maintenance cost is much lower. Nowadays, there are several model-based testing tools, and according to Bloor Research, test design automation is the ability to automate the entirety of the testing process, starting at an extremely high level. You can ask that if model-based testing is so good, then why it's not still widespread? The cause is that traditional model-based testing has some problems. First of all, the models should be so-called computer-readable, which means that an application should parse the model. And to do this, the model is overly detailed. It should consist all the UI elements, for example, press login or enter password and so forth. And that's why the model is implementation dependent because you can start the creation of the model when the application is ready. Otherwise, the application and the model will be different and you can do it again. And because of this, the in-sprint automation is very difficult. Another problem is the invisible path. When you generate the test cases from the graph, there may be invalid test steps. For example, if a step is to add the third pizza to the cart, the next step cannot be remove the second one, only the third one. To avoid this problem, we should write some code. This is the so-called guard conditions, and some other code is also needed. And there are some problems with the outputs because along different passes, the output can be different, and this is difficult to manage in the traditional model-based testing. That's why we introduced a new method, the two-phase model-based testing. We start from the traditional solution and we add another layer on top of the traditional modeling, which is a high-level model. The high-level model is human-readable, and from the high-level model, the complex or high-level test cases are generated immediately. And based on the high-level test cases, the testers or developers can execute the test cases manually. And when the tester executes the test case, immediately the low-level model and also the test code are generated, and we go back to the traditional solution. Here is an example to compare the high-level and the low-level model. The example is the password change, and during the traditional low-level model, the number of steps is over than 10, while by applying high-level model, there is only 3 steps. The first is an action, change the password, and there are 2 validations. First, let's check old password doesn't work, and let's check that the new password works. And I think that every tester can do it without any difficulties. As I mentioned, test automation requires test design automation and test execution automation. There are several tools for test execution automation. We selected Playwright. Originally, we started with Selenium, then Cypress, but there were many flaky tests. And when we applied Playwright, then the number of flaky tests lowered. So there are some, but quite a few. Okay, I'm not a Playwright expert, so I go to the next slide. The first step of our method is to create the requirements. Requirements are simple text in any languages, extended with some IDs, R1, R2, R3, and so forth. And the first phase is the high-level modeling. We created a new modeling technique because we realized that we need a model that includes states only optionally. States are very important. There are systems which do not require states, but there are other systems which require states. And if you omit states when these are required, then you will not find several bugs. On the other hand, if you use a stateful model for a system which doesn't require it, then the model will become more complex and less understandable. We also want a modeling which really doesn't require any coding. And finally, we need a model which requires only the checking of the outputs, but not precalculation, because precalculation of the outputs is difficult, and if you have a long test case with, for example, 40 steps, and you make a mistake at the 3rd step, then all the subsequent steps will fail. It's not good. Okay, and our solution called action state testing. Action state testing consists of action state model steps, and each step consists of an obligatory action, user action, 0, 1, or more system responses, and an optional state. Here is an action state model. You can see that it's very understandable because the graph part, I mean the nodes and the edges, are on the left-hand side, and the annotated text is on the right-hand side. Fortunately, only the nodes requires the text, which are the action, response, and the states. And here there are sequences where the steps will be executed one by one. There are forks. For example, you can see that fork, and the subsequent steps will be executed in different test cases. Okay, and finally we have joint nodes, joint steps, because for different test cases there can be the same test step. And you can see these green lines, which are the labels, and these labels connect the requirements and the model, and finally the test cases. Okay, from the high-level model, the test cases are generated on the fly, and later on, when the application is ready, you can execute them. From the action state model, the traditional state chart can be generated, and this model consists of less information because it doesn't consist of the responses and doesn't consist of how many times an action has been traversed, but it's very, very good for test selection criteria, and very good for validation, because you can easily check that this is a state, and some actions from this state is missing. And you can add the missing actions into the original model. Okay, and we arrived at the second phase. It's the test implementation. We use our tool called Harmony plus the playwright, and the model guides the tester what to do. For example, here you can see that the model step is add pizzas to reach 30 euros, and you can click on the appropriate pizzas, and the low-level test cases, which is Gherkin-like steps, are generated, and even these low-level steps are understandable for anybody. And when you are ready, you just click on Done. Okay, we can do this for the responses. The difference is that if you click on any input box, this will be considered as a validation. We have some interesting features as well. Fixing flaky tests take 1.5 times longer than the fair test, according to a Google case study. And the difference is that fair tests will always fail. You can execute them 1 million times, it fails. But flaky test passes or fails with different executions, and we exploit this because Harmony resolves flaky tests by re-executing only the fair test, and you can set how many times the fair test should be re-executed. On the right-hand side, you can see that MC15 first failed, but for the first retry, it passed. We also use some AI because, as I mentioned, we want a tool which is completely codeless, but the users sometimes need some extra feature, and we have a command when the tester can write a custom code. To avoid this, we made a prompt which consists of two parts. The A part is standard, you can copy it, and there is a B part, you should do it. For example, I asked Copilot to write JavaScript code where the input is the day shift from today. For example, -1 for yesterday and 1 for tomorrow. And this is the output format. And AI generated this very nice code. And considering the first line of the code, the user can use it for the subsequent test cases. Just click on the when selector receive date shift, and then enter the number, for example, 0 for today. Okay, so my conclusion. Test execution automation is not enough, but test design automation is also needed. We have a model-based testing solution where we apply a high-level modeling, which is implementation independent, a very good defect prevention method. Because during the modeling, you will find almost all the problems in the requirements. It's true, and it's better than any review technique, believe me. And the high-level model is very understandable. It supports both stateful and stateless modeling. It requires only a textual editor, but the results is a graph, which is very understandable. We have a flaky test recovery feature. Another good thing is that the outputs are only checked instead of calculation. And there is no need for debugging, really. If there is some problem, then it's better to delete some steps and do it again. It takes half minute, while debugging takes minimum 2 minutes. Okay, and that's all. Thank you very much. You can contact me and I will answer.
Istvan Forgacs'e sizin adınıza ben de model tabanlı test otomasyon aracı Harmony hakkında bize bilgi verdiği için çok teşekkür ediyorum. Şimdi